It is human nature to test the limits of what we can build, but engineers seem to see no limits when it comes to vehicles. With no task too big and no job too much, humans have created some of the most unimaginable vehicles to undertake some of the largest operations in human history. In today's video, we will go over 5 gargantuan vehicles. Before we begin, please make sure to hit the like and subscribe button to support this channel. Any aircraft expected to lift military equipment has to be large, but the Russians may have gone a little overboard with the Antonov 225 Mriya or Cossack. It has a wingspan of 88 meters, and with 6 engines it could handle 630 tons of cargo, the equivalent of 50 cars. It has a maximum speed of 850 km per hour, a length of 64 meters. It is still being used and was recently used to transport air defense systems to Turkey and Syria. It is so powerful that it even can carry a space shuttle on its back to be dropped off in mid-air for testing. Mining and massive construction projects need large trucks for the large jobs. This can do just that. The Caterpillar 797 is an autonomous-enabled earth-moving machine. It can hold over 680 tons of material, the equivalent of 15 loaded commercial airliners. It can also be operated without a driver, in autonomous mode like a Tesla car. This massive machine was designed by Caterpillar to transport material for high production mines and heavy-duty construction applications. The Prelude FLNG is the largest floating liquefied natural gas platform, as well as the largest offshore facility ever constructed. It was funded by Shell and costed around $12 billion. It works by extracting gas from below the ocean and liquefies it at minus 162 degrees Celsius. It can store the equivalent of 175 Olympic-sized swimming pools. When in operation, it can displace 6 times more water than the largest aircraft carrier. It is designed to withstand a Category 5 cyclone and has a length of almost half a kilometer.
There she goes, pile number 5, going up in the air. 16 of these is what's going to hold Prelude in place for the next 25 years in Cyclone 5 conditions.
Now we need to be a bit quiet because actually here we are running live plant. We are currently in the middle of steam blowing, and that means that we are running boilers. But what we do here is we generate steam, and with the steam we generate power, electricity, and the power that we need to be able to cool down the gas on the LNG side. So this is the heart. If we don't have steam, we will not have LNG, and we will not have anything else.
The well's now on, everybody's happy. So this will just continue, 24 hours a day, 7 days a week. This pipe's going just off the coast of Australia. We've got quite a way to go.
These guys, Material Handling Team 3. So these guys have the job of carrying the insulation from here up the staircases to the work faces. It's an essential part of the process. So we're going to give them out a little acknowledgement of what they're doing. Okay, JH Kip. We've got about 100,000 square meters, the equivalent to 20 soccer pitches or rugby pitches.
What's happening right now is we're about to install one of the flow-line jumper spools. Very important part of the whole system. It transports gases from the production manifolds over to the plant so we can get it to the FLNG. All the years of hard work, all need to come together now. So it's really time to be able to do it right.
When you go there day to day, it's a bit difficult to see, but when I take visitors around here, every one of them are totally impressed with what the project team has achieved, and I think everybody has delivered very, very well in 2016 and can be very proud of what we have achieved.
This beast's name is Bagger 288. This bucket wheel excavator is the largest machine in the world up to these days. Bagger 288 was built for the Rain Brown enterprise by German company Krupp in 1978. It took 5 years and $100 million to create it. Such monsters as this one are needed for minerals opening, for example coal, for digging trenches, for gas and oil pipelines, and for communication cables. Large beds of soil must be removed for the coal deposits development, where the bulldozers and excavators will work for several months. Bucket wheel excavators can deal in a few days. This machine takes more than 10,000 cubic meters of rock per hour. Bucket wheel excavators that are used for coal mining absolute size leaders. A German Bagger 288 has broken all records. Its weight of about 13,500 tons. Length 240 meters, height 96 meters, weight 46 meters. This monster's height is comparable to the height of skyscrapers. It digs 240,000 cubic kilometers of rock per day. It's like to fill a football stadium as a ball on a height of 10-story building. But it runs very slow, no more than a kilometer per hour. It takes several weeks to move from one mine to another. And also it requires tens of megawatts. To compare with, it consumes as much power as a small town need. And since we're talking about technologies, let's turn to the next engineering giant.
With us today is John Giles, the Crawler Transporter Project Manager, here to tell us a little bit more about the crawler. What exactly is the Crawler Transporter used for?
We will take the launch vehicles out to the pad and the ML and whatever anybody asks us to. And we've been doing it for over 50 years. Everything that's launched from pad 39A or B rode out there on one of our 2 crawlers.
So the Crawler Transporter is massive, and you said it goes at a top speed of 2 miles an hour. Is it because of how heavy it is? How much does the Crawler Transporter weigh?
So the crawler itself weighs about 6.6 million pounds, which is actually kind of small compared to we carry things that are 10, 12, 14 million pounds. So what we'll do is we'll travel underneath something. We'll go underneath it, we'll pick it up, like the ML, for instance, with the launch vehicle on board, and we'll jack it up, we'll take it out, we'll drop down to our cruising level, and then we'll go out to the pad on top of a specifically prepared crawlerway, which consists of about a foot of rocks, and then below the rocks are about 4 feet of hydraulically compressed limestone, and then below that is many feet of sand that's been compressed to support all of our weight.
Another question is, how do you see in front or behind you with how big the Crawler Transporter is?
So we will actually have a team of about 20 personnel that go with us the whole way out there that'll either be on board or walking alongside, and everyone will be on radios and in contact with each other, and the driver will frequently say, hey, somebody on the other side of the crawler, tell me how close I'm getting to this. So we have eyes all over it.
So one of the things that I've noticed is the pad, it goes up a hill, so to speak. So how does the crawler transporter handle bringing the rocket up there without it tipping over?
So the crawler has its own unique leveling system on it, and once it determines that we're out of level, we have what we call a GEL system, which stands for Jacking, Equalization, and Leveling, and it's basically a hydraulic system that once it's told by the manometer system to level us, will actually make adjustments and keep us at whatever level we want to be. So the incline going up to the pad is about 5 degrees, so as we go up to it, the crawler will actually articulate 5 degrees, so it keeps the ML and the launch vehicle on top.
So here we are in the engine room, what takes the crawler transporter from point A to point B. This is a very large engine, seems quite complex. What are the specs on it?
So this is an original engine that came out of a locomotive back in the 1960s. That's why you see ALCO here, American Locomotive Company. Same engine that would have rolled a locomotive down the tracks back then. It's V16, turbocharged, 2,750 horsepower.
So with an engine this size, how many gallons of gas does it take to operate it?
Takes a lot of gallons. We run on diesel, not gas. We carry our own onboard gas with us. We have 2 separate tanks, and they carry a total of 5,000 gallons of diesel fuel.
5,000 gallons. Now, how many miles per gallon does the crawler transporter get?
I'd like to say we get lots of miles per gallon, but it's really only 32 feet per gallon.
What exactly is this room used for?
So we're standing in the control room, and this is where the engineers will sit while we're rolling. And we'll have 3 to 4 engineers in here, and they'll all be monitoring these different screens. And on these screens, the engineers will see things like hydraulic pressures and the leveling system and steering and engine output and just everything we would need to control the crawler from in here.
So this is the crawler transporter driver's cabin. Now, is there any specialized training required to be able to drive the crawler transporter?
There is a lot of specialized training, and it probably takes at least a year to a year and a half of on-the-job training and driving of the crawler to be able to be certified.
Now, if you don't tell anyone, will you let me take it for a ride?
I'll let you sit in the chair, but I don't know if I'll be able to talk anybody into letting you take it for a ride, though.
So maybe after a year of training?
We'll start you in the next training class.
Well, John, thank you so much for coming out and sharing some information with us about the crawler transporter. Once again, I'm Yves Lamoth from the Kennedy Space Center, our multi-user spaceport.
If you enjoyed watching this video, please smash the like and subscribe buttons, and do not hesitate to leave me comments below for what you want to watch next.